let us look at this question to explain the velocity time graph. So we have a question on the board. Look at how the graph is drawn. And as you can see, this graph has formed three different kind of shapes. So from the graph, we are asked to find A, acceleration, then 2, total distance, 3, retardation, then the last one is what? Average speed. So from my previous video, I analyzed two scenarios where the motion of an object begins from rest. That means initial velocity is 0. But at this point now, this one does not start from rest. So it begins at u equal to 5. So this side represents the velocity and here represents the time. Good. Now, from here, what is given to us? Your initial velocity u equal to 5 meter per second. Then the final velocity, let us trace it to the highest. Okay, this is where we have acceleration from here to this place. The velocity increased from 5 to 10. So at that point, we have acceleration. So we have v equal to 15 meter per second. So from here, to calculate our acceleration, is going to be increased from here to here. That means like this. Then increase from here, this point, from this 5 to this 15. So your A is equal to V minus U all over the time it took from here. This point here is 0, okay? Then T. Now, what is a V? V here is 5. Okay, that is 15. V is what? 15. Then the U there, U is what? 5 all over. Let's look at the time. From here to this point is 5. So we divide by 5. This is equal to 15 minus this is 10, then over 5. We cancel out, we have 2. So acceleration is 2 meter per second squared. So we have solved that. So let us go to total distance. Total distance, like I said, is no longer the area of the trapezium, because in this shape, we have the first one here as trapezium, is A, labeled A. Then we have B as what? A rectangle. Then C is our triangle. Now let us find the area of all of them. Then we sum everyone together. So the total distance now is going to give us area in A, that is area in A, plus area in B, plus area in C. And what is the area of A? Area of A is what? The trapezium, which will now give us half ito. Where is our A? From here to here is our A. This 5 here, because look at the shape. So let us turn it upside down. So this is A, the shortest part, then which is 5 plus, where is your B? From this point, look at, trace it from here down to this point. Then you come down to this axis. That is what? 15. That is 15, because it starts from here. This is 0, this is 5, then that's 15. So half plus 15, then times, where is the height now? Look at the height from 0 to this 5. That is the height of the trapezium. Then times 5. Then plus area of B is just the rectangle we have from here to here as the length. This minus this is 5. We have 5 times, where is the breadth now? Look at the breadth. You see the same thing as equal to this side, which is 15. That is 5 times 15. Then plus area of this triangle. We have half base times the height. Look at here, the base, 15 minus 10. That's where we have the base, between here and here. So 15 minus 10 is 5. Then we have half times 5. Please, I'm just managing the board. Times 5 times the height. Where is the height? From here to here also. That is the height of the triangle, which is also 15. That's 15. Now let's begin to evaluate. So inside here we have 5 plus 15, that is 20. Then we have to now give us, sorry, let's clean it up. Okay, let's finish it here. Let's finish it here. All right. So we have 5 plus this is 20. Half times 20 times 5. I am just managing the board, so I'm actually looking for every means to get a very large board so that I can begin to teach flexibly. So here, plus here the area of this the rectangle is 5 times 15, that is 75, plus area of this triangle. So 5 times 15 is 75, that is 75 over 2. Now let us cancel out here. 2 here, 1, 2 here, 10. So 10 times 5, it gives us 50 plus 75. Then 75 divided by 2 will give us 2 into 7 is 3. Remember 1, 2 into 15 to give us 7. Remember 5. So let us sum everything together, and that will give us the total distance. So when you sum everything together, it will give you 162. So your x equal to 162.5 meter. So this one is the value for the total distance. Now let us go to the third one. Says retardation. Now retardation, this is where we have retardation at this point here. Now the velocity begins to decrease, and as you get to this point, the final velocity becomes 0, right? So your retardation now, is equal to, we should say v minus u, because it's still acting as acceleration all over what? T. So at this point now, this v here becomes 0. So then we are now moving with this one, this 15, which was originally the final velocity, has become the initial velocity, which now give us 0 minus 15 all over. What is the time interval here? That is the time with which the object begin to what? Come to rest. So that is 15 minus 10 is 5. So here, this also minus 15 all over 5, which is equal to minus 3 meter per second square. So this is your retardation. Now let us look at the last one. It says average speed. Average speed is denoted as, that is average speed denoted by what? Total distance all over the total time. Total what? Time. Or simply put, time taken. Now we have calculated the total distance. What is the total distance? Total distance is 162.5. Look at it here. Now let us just plug it into the formula. Let's plug it into the formula. We have total distance to be 162.5. What is the total time taken for this motion? Look at it here. This is the total time. It becomes over 15. Then finally, our answer, let's divide 162.5 divided by 15. It will give us 10.83 meters per second. So this is your average speed. This is how we use a velocity time graph to analyze motion and also to find the information we need from the motion. So if you find this class very interesting, help us to share this video to get to greater number of people on this platform. And if today is the first time you're just coming across me, please hit that like button, also follow for more updates, for more exciting videos. Or do well also to subscribe to my YouTube channel, Physics and Mathematics Lovers. Bye.